This is a lesson using trigonometric ratios in a relationship to word problems. We are going to be learning about two different types of word problems, one involving angles of elevation or one of depression. Now, an angle of elevation talks about somebody or something looking upwards from a specific angle. So I will either be drawing the triangles that look exactly like this, where the angle of elevation is going to be on the bottom right or on the bottom left, and that's always where that angle is going to be. I suggest drawing some type of image or diagram. Don't just try and write out the math for it. Same thing with the angle of depression, except from this example, normally you or the object is looking down from a certain height at something, and that angle is either going to be in this upper portion on either side of your diagram, just depending on how you draw it. So I have a couple examples of each of those two. And when you get to creating these triangles, if you want to draw specific images from the word problem, go for it. I don't need that as work, but I do want to see a triangle that you drew that still relates to the problem. And I will show you what that looks like in the third example when I don't have the pre-images already drawn in. So for example one, first I suggest reading right through the word problem and then going back and matching up what the information means. So it says, from a point on the ground, 25 feet from the foot of a tree, the angle of elevation of the top of the tree is 32 degrees. Find to the nearest foot the height of the tree. So the first thing I notice is the angle of elevation. So my image should look something like this bottom triangle here, and I know my degree should be in the bottom right or left, depending on how you draw your triangle. Then I'm looking at, it says, from a point on the ground, 25 feet from the foot of the tree, which is the base of the tree. So when I go to actually draw out my triangle, I would be drawing a base of 25 feet because it's saying from the foot of the tree to a certain point 25 feet away from it. So if I go to, let's see, a shape of some sort, and because I have an equation clicked. Shapes, let's do a line just so you can see what the triangle would look like. From this point onwards, it's going to be 25 feet long. So I'm going to also, let me just draw that, and always label your sides for yourself so that way when you get to the math makes it easier. This is going to be 25 feet from the foot of the tree to a certain point on the ground. And then I'm going to just fill in the rest of the triangle as it looks from up here. So let me just grab another line and draw that. And I'm using the tree as this side length here, but if you would rather just draw the triangle fully together, then you can just draw another line in. Again, now for me, I did not draw it specifically to the height of the tree, which is fine. It just, I guess I'll show you what that would look like. Let's extend this line. So the whole height of the tree, and let me fix my angle of elevation line here. So now we see this entire triangle, and it's always going to be a right triangle because right here at the base of your drawing, that is a right triangle, and you can assume that every time. Now it says this part is 32 degrees. So this is the angle of elevation. So let's also make sure we label that. And let's put in that 32 degrees. Sorry, I'm going a little slow in this video. I just want you guys to see what all the drawings will look like. Okay, so we have a base of 25 feet and an angle of elevation of 32 degrees, and it wants us to find the height of the tree. So that means that this height can be represented by, let's just call it X. So what I'm going to do is I'm going to put another text box, sorry, to show what side I'm specifically talking about, which is this height of the tree right here. Okay, now we want to think, what trigonometric operation do we think makes the most sense to use? So if I'm given this angle here, I see I have X is an opposite side and 25 feet is an adjacent side. So you're going to want to think about using the tangent ratio because you have an opposite and an adjacent side. So what you would do to solve for X is we would type in the tangent of 32 degrees is equal to the opposite is X over the hypotenuse, which is 25. And then when you go to the calculator to solve, your work that I want to see or need to see will look like 25 times the tangent of 32 is equal to x. Again, I'm just using inverse operations to get x by itself. So when I cross multiply, it's 25 times the tangent of 32. So in the calculator, that would be 25 times the tangent of 32 degrees. And that is going to be about 16 feet because it says to round to the nearest foot. So that means the height of this tree is about 16 feet. Now to go to the next example, once again, read through it, and then we're going to use this silly little picture to help us draw it out. So I see that it says, oh, if I can write correctly, from the top of a barn, 25 feet tall, you see a cat on the ground. The angle of depression of the cat is 40 degrees. How many feet to the nearest foot must the cat walk to reach the barn? So now we're using a picture that will look something like this because it says the angle of depression. So the first thing I'm going to do is actually start to draw out this image here. And then I'll fill in this side length because I want to make this top triangle complete. And so for the angle of depression, if we insert the shapes of our triangle, we're going to be starting here. And then we're going to have another line that is going downwards because it's an angle of depression to where the cat is. And then we're going to have to connect those two lines of the triangle together. That's close enough. And we know that our right angle then would be right in the top here. Now for angle of depression, our angle is always directly next to the image on the top. So our 40 degrees will be right up here next to the barn. So let's put that in its correct place. Here's our 40 degrees. And then it says from the top of a barn 25 feet tall. So this barn is 25 feet in height. So since I don't have this bottom triangle drawn, I can just assume that because this side length is 25 feet, that right here on my terribly drawn triangle is also 25 feet. I'm not grading you guys on drawings. It's more of that you have an understanding of what the image should look like. And I want to figure out how many feet the cat must walk to reach the barn. So that would be this side length here, because how far away is the cat from the barn? So our x would be our top portion of this triangle we drew, because I want to know how many feet did the cat need to walk to reach the barn. So once again, I have to determine what trigonometric ratio would work for this example. And I see that I would once again want to use tangent because I have an opposite side and an adjacent side. So I would be typing in the tangent of 40 is equal to the opposite, which is 25. Hold on, I'll move everything over x. And let's make sure we move that back. And then we're just going to do our inverse operations and actually be solving for x, and I'm going to write the work down here. So if I cross multiply, I have x times the tangent of 40 is equal to 25. And then I would know that I have to divide by the tangent of 40 to get x by itself. So that means x would be equal to 25 divided by the tangent of 40. So when I go to my calculator, 25 divided by the tangent of 40 is equal to about 30 feet for how far the cat has to walk, since we are rounding to the nearest foot. If you want to stop watching at this point, that is fine, but I have two more examples, and one is having no images at all, what it looks like. But if you want to continue watching, I have two more examples. So for example 3, it says Brian's kite is flying above a field at the end of a 65-meter string. If the angle of elevation to the kite measures 70 degrees, how high is the kite above Brian's head? So I know I'm going to be using something that looks like this triangle up here, but I have to think, what does it mean for the kite to be flying at the end of a 65-meter string look like? So I'm going to start by saying that whenever you're thinking of a kite, it like flies on an angle. So the part of that 65 would probably be referring to the hypotenuse. So the line is starting from some point on the ground, going upwards along a 65-meter string, and the kite would be somewhere up here in the sky. And then I'm just going to draw a triangle around that same idea. So when I insert that, I'm going to have one line here, and then I'm going to have one more line to connect my triangle together. Why isn't it letting me do that? Oh, here it is. Let's fix that up a little bit. Again, your triangle drawings, I'm not expecting to be perfect. When you're writing them, they'll definitely look better than what I'm trying to do on the computer. But this is what it would look like if you're starting with nothing. And then I'm just going to start filling in the different labels that it gives me. So it says Brian's kite, so here's Brian, is flying at 65 meters up in the sky somewhere along a string. So the hypotenuse is going to be 65 meters. And I know that the right triangle is always going to be where the two different side lengths connect. So our 90 degrees is right here. And if the angle of elevation is 70 degrees, my angle of elevation, just trying to be focused on using a diagram like this, is always going to be located in this bottom section. So I would have 70 degrees. Hold on, let's actually go back and use a text box. Drawn in the bottom of our triangle. There we go. And now I want to figure out how high is the kite above Brian's head. So this would be how high it specifically would be above his head if he was standing over here as well. So if I was to go draw where X would be located, X would be talking about the height of the triangle. And then I want to determine what trigonometric function I should use. And for this, I would probably think sine because it's opposite over the hypotenuse. So I would have the sine of 70 is equal to the opposite, which is x, over the hypotenuse, which is 65. And then we're going to cross multiply, and we'd have, oops, let's move that back in its place, of 65 is going to be really saying 65 times the sine of 70 is going to be equal to x, or the height. So we go back to our calculator, 65 times the sine of 70, and that means the kite is about 61 feet, or 61 meters above his head. In the last example, we're using the angle of depression, and I have the majority of it written out for you. I'm just missing one of the sides, which is fine. So it says you attend a music concert with some friends and sit halfway up the bleachers. So at that point, when you're drawing this out, you don't have to draw bleachers out. Just focus on the rest of the problem to see how you can make a triangle. And it says the angle of depression from your horizontal line of sight, so this would be your horizontal line of sight, is 24 degrees. So that's where angle of depression would go, which again also corresponds to this beginning definition up at the top. And then it says if your seat is 45 feet above the stage, that this is where your bottom triangle would be drawn. We are 45 feet up, and it wants to know what is our actual distance from the stage itself. So that is where D is. And I'm just going to draw in another line to show where the 45 feet is also referring to, and that's this section right here. So I also have a 45 feet notification for the top triangle as well. And if I'm trying to determine what trigonometric function I should use, I see that I have an opposite side, and I see that D is the hypotenuse, so I'd want to use sine. So in this example, I'd have the sine of 24 is equal to opposite, which is 45, over hypotenuse, which is going to be D in this example. And then when we cross multiply, I would be saying D times the sine of 24 is equal to 45. And then to get D by itself, I would divide by the sine of 24 on both sides. So then the next step for your work would be 45 divided by the sine of 24. And you go right ahead into your calculator, and we'd be saying, I'm sorry, I forgot the numbers. 45 divided by the sine of 24, and we are about 111